Okay, we're going to take on a more challenging question now that deals with velocity and speed. So we have a car that's traveling north for a bit of time, and then it goes south for a bit of time, and we want to find the average speed and the average velocity. So now we're moving on into an excellence level question. Now, for this one here, when we're finding the average, you can't just simply take the 77 and the 49 and add them together and divide by 2. That does not work here. And you shouldn't think it would, because this question might be worth about 6 marks in total. It can't be that easy. The first thing you have to do is you have to find the distances traveled for each leg. So that's what we're going to do first. We're going to find the distances. And so we can use the formula V is equal to d over t, get d by itself. So d becomes equal to vt, but there's 2 different legs to this journey. So we'll start with d1, which is 77 kilometers per hour, and the time here is 3.8 hours. So that would be the length for the first part of our journey. And that gives us 292.6 kilometers. And I'll just put in brackets here that that's going towards the north. We could do the same thing for the second one. So that's going to be 49 times 2.6. So about 127.4 kilometers, and that's going towards the south. Okay, so that's step 1. Then what I recommend you guys do is draw this diagram. So I'm just going to do this over here on the side. So first it travels 292.6 kilometers north. So it's 292.6 kilometers. And then from there, it then travels down or to the south at 127.4 kilometers. Okay. And what I'll do also, just to keep the information here, this first part is for 3.8 hours, so I'm just going to put that in brackets. And the second leg of the journey is 2.6 hours. Okay, just so I don't have to keep on scrolling up and down. Excellent. Now, step 1, or the first thing we're looking for, maybe I'll change the color here. So the first thing we're going to look for is average speed. Now the great news is that speed is a scalar quantity. So the formula we use for speed is simply v is equal to d over t. Now if you want to get technical, v average is simply the total distance over the total time. How far did you travel? How long did it take? So for the overall distance, we simply do the 292.6, add on to that the 127.4, and divide it by the times, 3.8 hours plus 2.6 hours. It really is as simple as that. Overall distance, overall time. Make sure you use brackets on the top and the bottom. All right, so this comes out to be about 65.625. This question has only 2 significant digits. So that comes out to be 66, and the units will be kilometers per hour. So you don't use positive or negatives. You don't show direction. It's just strictly scalar all the way through. All right, I think I'm going to add another page here. Just bear with me for a second. Add a page. Okay, good. I'll get rid of that. Okay, I'm going to take this diagram here. I'll need it for my next part. Just going to copy that. The wonders of technology. Bring that over to the side. Okay, now we're ready for the next stage. What we're going to look for now is the average velocity. Okay. And it turns out to find average velocity, the key here will be first of all figuring out what the overall displacement is, because we know the equation for velocity is displacement over time. It's a vector quantity. And technically, overall total displacement over overall time. So this is kind of our governing equation. But the challenge for this one is to find the overall displacement. And this is actually a bit of a review for you guys. So let's talk about the two different ways we can find the overall displacement. The first one is this. Displacement goes from where to where, or it is your what to what vector. Answer, it's your start to finish vector. So you notice that we started down here and we finished up here. So going from start to finish, that is our overall displacement right there. So some of you will be able to look at this diagram and you know how to find the displacement. But there's another method. Now we introduce a reference system. So I'm going to choose north is positive and south is negative. So this first one was going to be a positive displacement and the second one's going to be a negative displacement. And when I'm looking for the overall displacement, the first thing is don't use d final minus d initial. We do not know positions in this question. These two happen to represent displacements. So if you're going to do the equation approach, we're basically going to add displacement 1 plus displacement 2. And this is going to become 292.6 positive plus negative 127.4. So you notice that this effectively means we just subtracted the two. Hopefully that's what you were thinking. So 292.6 minus 127.4, and that comes out to be 165.2 kilometers. And notice it comes out to be positive, so it's going towards the north, which is shown in the diagram. Finally, we can find V average. So V average, therefore, becomes essentially just delta D1 plus delta D2 over T1 plus T2. You'll notice that equation looks very similar to one that we used here for overall distance over overall time, which is D1 over plus D2. So similar idea. And therefore this one comes out to be overall displacement of 165.2 kilometers over the total time. Again, that's 3.8 plus 2.6. So that's about 25.8 kilometers per hour, and it comes out to be positive, and positive means to the north. This is a vector quantity, so you have to show the direction of velocity as well. Good? Okay. So if you're doing a question like this for average speed and average velocity, the most important things to keep in mind. First is this. You have to find the distances before you actually can find the speed and the velocity. Don't just add the numbers and divide by 2. The second most important thing is to make sure that when you're dealing with velocity, you deal with it as a vector. It all comes down, by the way, to this part right here. Knowing how to find the overall displacement. If you got that, then you're set for this question. Okay, there's just one more small thing I want to show you here. And that is how to find velocity on a position time graph. You have one question that involves that. So let's see if we can answer these questions. Here's a position time graph. Do you remember what the title is for every graph? Answer, it's always y as a function of x. In this case, that would be d position as a function of time. Good. Next, let's imagine we wanted to find the slope. Now, if you find the slope, you're going to be doing rise over run, which actually comes out to be delta y or delta d over delta x, which is delta t. Do you guys know what is delta d over delta t by definition? Answer, velocity. So you'll notice that when you have a position time graph, this is a position time graph, the velocity just simply represents the slope. And just in case you're interested, notice how this is a straight line. Now in math, we know that a straight line has a constant slope. Now if it has a constant slope, that means it's going at a constant velocity, because slope is velocity. If it's going at a constant velocity, if the velocity doesn't change, we call that uniform motion. So on a position time graph, uniform motion is a beautiful straight line. Okay, so now you can do that one homework question as well that involves the graph. If you want to find the velocity, just simply find the slope. Easy as that. Okay, good luck with the homework.